maximum power theorem. The maximum power delivered to a load resistor makes most sense when one has a Thevenin equivalent because of its simplicity and clearness. So the circuit looks something like this. And we have our load. And here's our load. And of course, this is R Thevenin and V Thevenin. The maximum power transferred from the power supply to the load implies setting dp load with respect to the R load is set to 0. And one determines the critical point. So writing out the details of P load using VDR to calculate the voltage of the load, P load equals V load squared over R load. Now we use the voltage divider rule to get the voltage of the load, and we write that the voltage of the load should be the sum of the resistors plus divided into R load times VTH. So if I plug this in and reduce it, I get an expression that reads R load plus RTH quantity squared divided into R load VTH squared. Now we take the derivative of this to get the critical point. So taking the derivative of this I spelled derivative wrong, so let me try that one more time. Taking the derivative of this yields that I get I get that the derivative of P load with respect to R load is then going to be the derivative of that quantity up there, which means that I have R load plus RTH squared. And then I have into R load. Now note that there is this VTH squared term, but we don't care about this. This is a constant, and we can divide it out from both sides, and it's this guy that has to be equal to 0. So if I now do the derivative, I get the following thing. It then says that this guy is then going to equal to take the derivative of the load, that's 1, times the denominator minus the derivative of the denominator, which will give me 2 R load plus RTH times the numerator divided by the whole quantity R load plus RTH squared, which will give us to the fourth. And this is what's equal to 0. This is only true when the numerator, numerator is 0. So if I focus on the numerator, I then write that I have R load plus RTH squared minus 2R load times the quantity R load plus RTH is equal to 0. But note, one of the powers cancels out. So if I just factor out R load plus RTH, we then see here that the condition, that the critical point for maximum power is R load equal to RTH. So if I now substitute that back in, we could then calculate the maximum power.